This is our new Digital Antenna Selector, also referred to in shorthand as the DAS. Used in conjunction with the 87A, as I mentioned, this allows extreme flexibility in automatically selecting antennas. The two rows of push. The DAS is capable of being operated in either of two primary modes. In the simplest mode, the push buttons along the top row, numbered 1 through 6, plus these three, which are double labeled, but in one of the labels is 7, 8, and 9. So buttons 1 through 6, 7, 8, and 9 can be used along with their associated LED lights to select from anywhere between 2 and 9 different antennas just by a simple push of the button for manual selection, or a pre-programming process whereby the antennas are selected automatically, which I'll demonstrate in a minute. In the more complex and more flexible mode, the DAS can control selection from an array of up to 36 antennas. Here's a rough sketch of a full 36 antenna setup. The feed line from the amplifier comes into a local relay box with 6 possible outputs. Each of those output feeds an additional 6-way box. So these don't have to be 6-way boxes. All of them could be one-way, not one-way, but 2-way, 3, 4, 5, or 6. And they're typical remote relay boxes, such as those manufactured by DX Engineering. In addition, then, each of these 6 boxes is capable of feeding up to 6 different antennas, and I've expanded on that a little bit with box D, showing that of these 6 outputs there could be 6 different antennas connected. And the designation of each antenna is very simple. The letter selection in a 1 of 36 system, the letter selection from the bottom row of buttons on the DAS, down here, A, B, C, D, E, F, that selects which of the remote boxes will be selected or switched in, and then the number on the top row of the DAS, 1 through 6, corresponds to which output is selected from the appropriate box. If, for example, I press the buttons D4 with this particular sketch, that means that the amplifier, the entire station, would be connected through this box out to remote box D and to antenna number 4. If I pushed A4, it would be connected to box A, antenna number 4. A1 would be the antenna connected to output number 1. And the cabling required to interconnect all of these things is very simple as well. And I have my station antenna system set up a little differently to take full advantage of the DAS capabilities. As you can see, I use 3 relay boxes. These all happen to be 5-way DX Engineering boxes. 2 that I describe as local boxes because they're right here in the station, and the third one is located on a tower about 250 feet away. The 2 local boxes are both driven by the circuitry that corresponds to the DAS front panel buttons A through D, or A through E actually. They're driven in parallel, and the remote box has 5 outputs which correspond to outputs 1, 2, 3, 4, 5, or buttons 1, 2, 3, 4, 5. So, for example, this 20-meter Yagi is output 4 from the remote box, and since I don't want to insert an L network for matching on 20 meters, I have a good match across the band with the antenna, I select a straight through connection between these 2 boxes. So when I program 20 meters to select antenna D4, the connection from the amplifier and the station comes through the local box, goes output D. D goes to just through a coax jumper to D on the other local box, and through there to the remote box to output 4, which is 20 meters. Likewise, the 15-meter beam, this is a little blurred, but the 15 meter is D2. It's output 2 here, and also it does not pass through. It does not pass through a matching network. On 80 meters, the sloper tends to have an SWR of as much as 2 or 3 to 1, sometimes 4 to 1 in various parts of the band. And the easiest way to handle that is to have a matching network. I happen to use a reversible L, just a single band L, which is switched in when I select outputs E on the local boxes. So E3 is the 80 meter sloper. It happens not to be connected at the moment. Similarly, 40 meters, the 40 meter 2-element beam is well matched at band center, but SWR gets up around 2 to 1 on band edges, and for best efficiency, best happiness of the amplifier, I like to match it. It really isn't necessary. So the 40 meter output is B on the local boxes, which routes it through a 40 meter L network, then out here and out through output number 1. So 40 meters is B1. Now my original antenna, which is on a pole close to the house, is fed by its own, well, I might add this 250-foot run is hardline, and the advantage, of course, of using the switching boxes is saving of coax. These 2 boxes take the place of 3 additional runs of coax and make it very cost-effective to use hardline here. An arrangement that many much larger stations than mine now use for to keep losses to a minimum on the line and so forth. But in this case, because of the long run, it was useful even for a rather modest antenna system such as I have. The local antenna, the KT34A tribander, which I keep for backup use and so forth, is simply fed directly, so that if I select on the local box the output A, that line goes directly to that tribander, and the other boxes are not involved. So taking account of the fact that my 80 meter antenna at the moment is disconnected, let's widen this out a little and see if we can see the summary, the little cheat sheet here. On 10 meters, I select A or A1, although a numeral really isn't necessary. On 10 meters, it's A or A1 for the tribander, 15 meters likewise for the tribander. On 20 meters, I select D4, or I want D4 to route me directly through to the 20 meter long Yagi, unless, of course, I choose to compare antennas, and then I merely need to switch to A1 to use the Yagi for comparison. But I want to program the switch to pick D4. On 40 meters, we pick B1, which takes the feed line through the L network here and on out to the 40 meter beam. 80 meters, since the antenna is temporarily disconnected at the tower, along with the work bands, for which I haven't yet got the antenna up, are all routed through output C, which is hard to read, but this is output C of the first local box directly into a dummy load. So this is how I want to program the antenna system. So let's just keep this here for reference. And I'll show you how the programming is actually accomplished.